So the next type of function is our trig functions, and obviously we've been working with those for a while now, but one of the things we don't know how to do yet is how to differentiate and integrate and so on, so we'll come to that. But we'll look at a couple of other things whilst we're looking at trig functions. And just a reminder though, radians is an alternative way of measuring angles, and when it comes to calculus, and we'll see this in a couple of lessons when we look at the differentiating, it becomes very important. We need to use the radian measure rather than the degree measure for the maths basically to work. Okay. So the conversion, I like to think of it as 360 degrees is 2 pi, because I can get my head around that easier, because I think 360 degrees is a full circle, and we know the circumference of a circle is 2 pi r, so I can relate 360 and 2 pi very easily. But basically it's pi is 180, of course. All right, arcs and sectors. That's a circle, by the way, just in case you've forgotten. Okay, we know the circumference of that circle is 2 pi r, or pi diameter, whichever you prefer. And we know the area is, of course, pi r squared. But if we're not interested in the whole shape, but just a piece of it, then if I was just to, let's draw in a sector. There we go. The angle at the centre we're just going to call theta. Now, AB is an arc. Now, depending on which way around we go, we call it a major or a minor arc. So the smallest or the shortest distance between the two would be the minor arc, and the larger distance would be the major arc. If they don't specify, we would normally assume they're talking about the minor arc rather than the major arc. Okay. L, I'm going to use for the length of that minor arc there. So I know it's a ratio of the whole circumference, and that ratio comes down to the angle at the centre. The whole thing, and I've put it in radians, and hopefully you can see why we use radians for this, because the 2 pi's then nicely cancel. So theta divided by 2 pi radians for the whole circle, and we get a very simple formula then, that the length is equal to the radius times the angle at the centre, but remember that angle needs to be measured in radians for that formula to work. And we can do a similar thing with the area. So anyway, length of arc, L equals r theta, and our sector, again, that proportion of the whole circle, so that proportion of pi r squared, and we get a half r squared theta. So there's our two new formulas, formulae, whatever the plural of formula is.
Is that also in radians?
That's also in radians, yeah. So it needs to, so that the pi's ended up cancelling in the formula. So we needed to make the whole circle 2 pi radians rather than 360 degrees. Okay, let's do a simple little example. And I've purposely made that 45 degrees to highlight, hey, before we can do this, we need to change that into radians. Okay, so the length of AB will be r theta, but not 45 degrees, pi on 4 radians. And so the exact value would be 5 pi on 4 centimetres, which would be whatever, 5 times 3.1415926, 535897932384626433833279 approximately is. Okay, and the area of our little sector there, half r squared theta, again subbing in pi on 4 rather than 45 degrees, is 25 pi on 8. Okay, now the minor segment, if we want to find a segment, so we draw the chord in, and it again splits the circle into 2 segments, the minor one being the smaller segment, major one being the larger segment. If I wanted to find that area, well, it's basically the area of the sector minus the area of the triangle. So we could come up with a formula for that. Half r squared theta is the sector, and then if I use our sine formula for the area, half AB sine C, but in this case, A and B are both the radius, and theta is the angle, so we get half r squared sine theta, common factor of a half r squared, theta minus sine theta. Now, whether you memorise the formula or you just do it from scratch each time, and you say, oh, well, it's the sector minus the triangle, it doesn't really matter. As long as you know where it comes from is the main thing. So our one, substituting in, ends up being this wonderful number, 25 pi root 2 minus 100 all over 8 root 2 centimetres squared, but I'm sure you would have guessed that anyway. So in the real world, we would go to our calculator and give us an approximation, because imagine if you were ordering something and they say, oh yeah, about what size area? Oh yeah, well 25 pi root 2 minus 100 over. Not really practical. Okay, so 14b, just a quick little exercise on applying that formula. That'll do us. We've only got a single today. How unusual.